Hello everyone. In this video, we'll be seeing how to solve Lagrange's equation. So first, we have to know what is meant by Lagrange's linear equation. So an equation of the form that is PP plus QQ is equal to R. This is called as a Lagrange's equation. So note that the small p and small q represents the partial derivative of z with respect to x and partial derivative of z with respect to y, where all other terms, that is capital P, capital Q and capital R, these are functions of the variables x, y and z. So if we have an equation in this form, that equation is called as Lagrange's equation. Now, in order to solve this type of Lagrange equation, particularly we have to know the following subsidiary equation. Subsidiary equation is nothing but writing dx divided by the term p equal to dy divided by the term q and dz divided by the term capital R. Also, this equation is named as Lagrange's auxiliary equation because using this equations only we'll be able to find the solutions. So, after writing the subsidiary equation, we'll be able to determine two solutions. That is, u is equal to a and v is equal to b. Two solutions. So, if we are able to determine such a solution, we can write the solution for the given Lagrange equation will be phi of u comma v is equal to 0. Now there are two methods to find these solutions for the subsidiary equation. So the first method is method of grouping and next one is method of multipliers. So first one, let us see what is meant by method of grouping. So in method of grouping, the variables, it can be separated in any pair of equations. For example, we can either take these two pair or these two pair or the pair 1 and 3. So after pairing this equation, we have to solve it to find the two solution. U is equal to A and V is equal to B. After finding those solution, we can write phi of u comma v is equal to 0, which will be the solution of the given Lagrange's equation. So let us see some problems in this method of grouping. So take problem number 1. We can clearly see that here it is in the form of capital P. So here we can take capital P as x, capital Q as y and capital R as z. So it will be in the form of PP plus QQ equal to R. So capital P will be x and capital Q it will be y and capital Z capital R it will be Z. So that's what written here. So the given equation is in the form of PP plus QQ equal to R. So now then we have to write the subsidiary equation. As I have told earlier, you have to write dx by P equal to dy by Q equal to dz divided by R. Now substitute the terms correspondingly. Dx by x, this will be equal to dy divided by y and this is equal to dz divided by z. Okay. So now we are going to pair this equation. First I am going to take the pair first two things. Dx by, that is dx divided by x equal to dy divided by y. So always note that after taking the pairs, we have to bring x terms to one side and another variable terms to another side and then we are going to integrate. So now see that we are having dx by x and dy by y. Clearly all the variables are kept in one side. Now let us integrate it straight away. Now can you tell me what is integration of 1 by x? Integration of 1 by x will be log x. Similarly, integration of 1 by y with respect to y will be log y. Since both the term contains log, I am going to put the arbitrary constant, that is integrating constant, as log a. Okay. So now you can bring this log y to left hand side. We can write it as log x minus log y this will be equal to log A. So now log A minus log B, it is nothing but log A by B. So this can be written as log of x by y, which will be equal to log A. Now we can cancel log on both sides, or you can take exponential power so that E and log will get cancelled. So this implies x by y, this is equal to A. We have find one solution. So this x by y represents the function u. And similarly we have to take another two pair. So I'm going to take the last two pairs, dy by y and dz divided by z. So since all the variables are kept in one side, I'm going to integrate it straight away. So after integration, 1 by y, it will be integrated and we'll get the answer log y, and right hand side integrating 1 by z with respect to z will be getting log z, and I'm going to put the integrating constant as log b. So now similar to the previous equation, we can bring log z to left hand side, and using log property we can write it as log y by z equal to log b, and now this can be written as y by z is equal to b. So this is our second solution. So this term is taken as b. So now since we have obtained both the terms, that is u is equal to a and v is equal to b, we can write the final solution, that is phi of u comma v, that is nothing but phi of x by y comma y by z, this will be equal to 0. This is the required solution for the given Lagrange's equation. So now let us move on to next problem. So see here, here the function is given as y square z by x p plus x z q, this is equal to y square. So what we are going to do is, since there is a division term here, I am going to multiply by x throughout in this given equation. So you will be getting y square z p plus x square z q, this is equal to xy square. So our capital P term will be y square z, and capital Q term will be x square z, and capital R will be xy square. So that's what written here. After writing the terms P, Q and R, we have to write the subsidiary equation. So subsidiary equation is dx by P equal to dy by Q equal to dz divided by R. So now substituting the terms, we will be getting dx by y square z and dy divided by x square z and dz divided by xy square. So now I am going to take the first two pairs, that is dx divided by y square z and dy divided by x square z. So clearly we can see that in left hand side the integrating variable is dx. However, the term contains y and z. So we have to change this one. So now z and z can get cancelled, and if I bring this x square term to left hand side and y square term to right hand side, I can write this one as x square dx equal to y square dy. Now all the variables are same in both the sides. So now we can integrate it. So integrating x square dx equal to integrating y square dy. So doing integration, we know that it will be x cube by 3 and this will be equal to y cube by 3, and I'm going to write some integrating constant c1. So we can bring this term x cube by 3 minus y cube by 3, this is equal to c1, and this can be written as x cube minus y cube is equal to 3c1. I'm going to name this 3c1 constant as a. So I'll be writing x cube minus y cube, this is equal to a. So this x cube minus y cube will be our first solution u. And next one, I am going to take the terms first and third, that is dx divided by y square z, which will be equal to dz divided by xy square. And here also we can observe that the terms are misplaced. So I'm going to cancel y square on both sides, which is very obvious. Now I can bring this x to left hand side and z to right hand side. So I'll be writing x dx. This will be equal to ez dz. Now integrating on both sides, I can write this one as x square by 2 equal to ez square by 2 plus some integrating constant c2. Already I have taken that integrating constant c1 for the previous derivation. So now it can be written as x square by 2 minus z square by 2 equal to c2. So this can be written as x square minus z square equal to 2c2. So it is nothing but x square minus z square equal to b. So this x square minus z square will be the next solution b. So the required solution will be phi of u comma v, which is nothing but phi of x cube minus y cube comma x squared minus z squared. This is equal to 0. So this will be the solution for the given Lagrange's equation. So let us take this third question. So clearly it is given in the form of pp plus qq equal to r, and capital P is nothing but x squared, capital Q is y squared, and capital R it is z squared. So the subsidiary equation will be dx by p equal to dy divided by q equal to dz divided by r. So the replacing the terms will be getting dx by x square, dy divided by y square, and dz divided by z square. So this is the subsidiary equation. Now taking first two pairs, we'll be getting dx by x square, this is equal to dy divided by y square. And since all the terms are in one side, we can integrate it straight away. And note that during this integration, we can write that as x power minus 2 dx. This is equal to y power minus 2 dy. And if we integrate x power n, we'll be getting x power n plus 1 divided by n plus 1. So here it is nothing but x power minus 2 plus 1 divided by minus 2 plus 1 dx. So this can, so dx will not be there. So integrating this one, we'll be getting x power minus 2 plus 1 divided by minus 2 plus 1, which is nothing but x power minus 1 by minus 1. So we can write it as minus 1 by x. This will be equal to minus 1 by y, and I am going to write some integrating constant c1. So we can write it as 1 by y minus 1 by x. This is equal to, the constant can be replaced with a. Or we can write 1 by x minus 1 by y is equal to a. Now taking the first and third term, that is dx by x square equal to dz divided by z square, and integrating it, we'll be getting minus 1 by x equal to minus 1 by z plus some integrating constant b. So after this one, we can obtain 1 by x minus 1 by z is equal to b. So clearly this will be our u term and this will be our v term. So the required solution will be phi of u comma v. So we can write it as phi of 1 by x minus 1 by y comma 1 by x minus 1 by z. This will be equal to 0.